A polyprotic acid is an acid that donates more than one proton to the solution it is in. Because the acid loses more than one proton, it has multiple acid ionization constants, Ka for the first proton lost, Ka for the second, and so on. For example, phosphoric acid, H3PO4, has 3 Ka values for the 3 protons it can donate. Ka1 has a value of 7.5 times 10 to the negative third, Ka2 has 6.2 times 10 to the negative 8, and Ka3 is 4.8 times 10 to the negative 13. Since there are 3 Ka values, there are also 3 pKa values. pKa is the negative log of the Ka, and for phosphoric acid, pKa1 is 2.12, pKa2 is 7.21, and pKa3 is 12.32. The titration curve for a polyprotic acid is very different from the titration curve for a monoprotic acid. Since 3 protons are being donated, there are 3 half equivalence points, where the pH equals the pKa. There are also 2 equivalence points, where the moles of titrant are equivalent to the moles of analyte. Consider the titration of 50 milliliters of 1 molar H3PO4 with 1 molar NaOH.
To solve this problem, set up an ice table. Then, use the Ka to solve for X, the concentration of H3O+. Take the negative log of this to get to pH. When 25 milliliters of NaOH is added, we are halfway to the first equivalence point. This means the pH equals the pKa. When 50 milliliters of NaOH is added, we are at the first equivalence point. Therefore, the pH is equal to the average of pKa1 and pKa2. When 75 milliliters of NaOH is added, we are halfway to the second equivalence point. Therefore, the pH is equal to pKa2. After 100 milliliters of NaOH has been added, we are at the second equivalence point, so the pH is equal to the average of the second and third pKa's. When 125 milliliters of NaOH has been added, we are halfway to the third equivalence point, and the pH equals pKa3. After 150 milliliters of NaOH has been added, we are at the end point of the titration. The Kb is equal to Kw divided by Ka3. Make an ice chart to solve for the concentration of OH- in the solution, since it is now a basic solution. Use the Kb to solve for X, the concentration of OH-. Take the negative log of that concentration and subtract it from 14 to find the pH of the solution.